Friends, consider the first order differential equation, namely dn divided by dt is equal to plus or minus lambda into n, where lambda is a proportionality constant. So we know that clearly it is a differential equation, or I can say that clearly it is a first order differential equation. One point is to be noted: this equation is called differential equation because it is containing a derivative, and I can say that it is a first order differential equation because highest derivative present in this equation is first derivative. That's why it is called first order differential equation. So this simple equation represents many things. So I can say that I can treat it as a mathematical model to represent a radioactivity decay. Suppose if I consider a negative sign, it means suppose if I write like this: dn by dt is equal to minus times of lambda into 1. Not only a radioactive decay, for any decay problem, the equation can be written down in this form: dn by dt is equal to minus times of lambda into n. So for example, now I want to handle any temperature problem. It means temperature decreasing problem. In that case, I can write down, roughly I can say that I can write down the above equation in this form. Right? So this is one possibility. Another possibility is I can consider dn by dt is equal to plus times of lambda into n. So this equation can be represented any growth problem. So for example, if I want to study a population growth problem, in that case I can consider dn by dt is equal to plus times of lambda into n. Or if I want to study any bacteria growth problem, in that case also I can consider this equation. So now I want to consider one by one. Suppose if I consider minus times of lambda into n, what it represents physically. See, I want to go for Newton's law of cooling. What we know that Newton's law of cooling. So you may ask, what do you mean by Newton's law of cooling? So Newton's law of cooling states that the rates of change of the temperature of an object is proportional to the difference between its own temperature and the ambient temperature, or what we call it as an room temperature. Is it clear? So suppose now I want to transform this word or these words into an equation, right? So can you tell me what you will get? I can write down a similar type of equation. So same Newton's law of cooling can be written down: dt by t is equal to minus times of k into the difference between temperature. So here TA represents ambient temperature or room temperature. Capital T represents temperature of the body, where K represents proportionality constant. Right? Here we want to consider it as a minus K, where K is greater than 0. Is it clear? Okay. So now I want to verify whether is it a differential equation? Yes, clearly it is a differential equation. Or I can say that clearly it is a first order differential equation because highest derivative is dt, capital T, divided by small t. Okay, now I want to find out the solution of this differential equation by using a very simple method, namely variable separable method. I can find out the solution of this equation. Solution plays an important role. Suppose if I want to note down temperature in a particular period, right? So this equation, or means the solution of this equation, tracks the complete record of the temperature over a time. Okay, now how do we find out the solution of this equation. Say, for example, I can write down dt divided by t minus ta is equal to minus times of k into dt. You can cross multiply. So now I can integrate on both sides because I can say that variables are separable. Suppose if we integrate, so what I can obtain, log of t minus ta is equal to, minus k is a constant, I am going to integrate dt, so I can obtain c plus, sorry, minus times of k into t plus constant of integration, I want to call it as an c naught, right? So I want to remove log left hand side, I can write down t minus ta is equal to, if you remove the log, what I can obtain right hand side, so e to the power minus times of k into t plus c naught, or I can write down c into e to the power minus k into t, right, where c is equal to e to the power c naught. Okay, or I can write left hand side t minus t suffix a, right, or I can write down t is equal to, capital T is equal to ta plus c into e to the power minus times of k into t, right? Or here capital T is a function of small t, or the same equation can be written down in this form, c into e to the power minus times of k into t, where the arbitrary constant c will be calculated by using the initial condition, small t means time is equal to 0 is equal to some constant, say t naught. So it means, so this equation represents the solution of the first order differential equation, namely dt divided by dt is equal to minus times of k into t minus ta. It represents a Newton's law of cooling, and solution represents the complete tracks of the record of the temperature over a time. Thank you.